Hello everyone, welcome back to my channel. Today let's solve Leetcode problem 2070, most beautiful items for each query. Okay, what does the problem statement state? It says you are given a 2D array items where items of I is basically price I, beauty I, denotes the price and beauty of the item respectively. You are also given a zero indexed integer array called queries, for which queries of j. For each queries of j, you want to determine the maximum beauty of an item whose price is less than or equal to queries of I. Okay. If no such item exists, then return 0. Okay. Now we have to form answer array with this particular criteria. Okay. Let's take an example. Okay. We have been given items as this and queries as this. Okay. For query 1, okay, we have to see what all items has price less than or equal to 1. In this entire array, we only have this particular array whose price is less than or equal to 1. So the maximum beauty which we can get is actually 2, which is 2. Okay. Now let's take another example 3. Okay. So we have to search for all the items whose price is less than or equal to 3. So this arrays this array, and these three along with this all falls in the desired bucket. Among these 4 arrays, what is the maximum beauty? Among 2, 3, 4 and 5, the maximum beauty is 5. As a result, the 5 would be the answer. Okay, so let's jump into the editor. Okay, so what we have done is basically for each query, okay, yeah, so for each query we have to basically look for all the items which are less than or equal to that particular query. Okay, so for 1 we have 1, 2, only 1, 2 we have, so the maximum beauty which we can get is 2. Okay, let's take the second one. Okay, so what all items whose price is less than or equal to 1, 2, 3 is not less than 2, so we have 2, 4. Yeah, only these two products falls under the desired criteria, so the maximum beauty which we would get is basically 4 in this case. Okay, let's take 3. If you take 3, so what all items are less than 3 whose price is less than 3? 1, 2, 3, 2, 2, 4 and 3, 5, right? So what is the maximum beauty among all these things? Among 2, 3, 4 and 5, what is the maximum? The maximum is 5, so the answer would be 5 in this case. Okay, so for every query we are basically looking for all the items which are less than or equal to the particular query whose price is less than or equal to the desired query. Okay, so the brute force would be take each query and look for all the items which are less than that particular query whose price is less than the particular query and get the maximum among those values. So it would be order of n square. Okay, so let's try to think, can we maximize this? Okay, how can we minimize the time complexity in this case? Okay, so before that let's try to sort the array. Okay, if we sort the array, it would be 1, 2, 2, 4, 3, 2, 3, 5 and 5, 6. Okay, so for a given query I have to only look for the elements whose price is less than 1, right? For a given query I have to only look for items which are whose price is less than 2, right? For a given query, right, for a given query I have to only look for items which are whose price is less than 3, right? If you see the search space, we have reduced it. Previously we are, for each element we are actually searching for the entire array. Now that we are actually searching for a lesser space. Okay, so some benefit we have got, but still for each query we are still looking, right? Again here the time complexity would be order of n square. for sorting, the time complexity would be n log n, right? So this would be the time complexity for sorting. So like our motive is to basically get the maximum, right among all the items whose price is less than or equal to our query. We want the maximum among all those things, right? So we can simply iterate once and keep maximum so far, right? So let's try to populate it. We have 1 comma 2. Since we have only one element, this would be the maximum, and we know this is the maximum so far, right? So for the current element, right, we have to just compare with the max so far. Okay, so among 4 and 2, what is the maximum? 4. So we will be having 4. Among 2 and 4, what is the maximum? Maximum would be 4. Among 5 and 4, what is the maximum? 5. Among 6 and 5, what is the maximum? 6, right? So we know for a given query what is the maximum so far, right? We know the maximum so far. So all I have to do is basically search for the item with the maximum beauty, right? So let's say I'm looking for 3, right? Let's say I'm looking for 3. Okay, so since elements are in the sorted, since all the prices are basically sorted, I can take use of binary search, take benefit of binary search. Okay, so the time complexity in this would be log n, right? I don't have to do the linear scan, I can simply do the binary search. This way the search space will be, every time it will be reduced by half. Okay, so when I'm looking for 3, so let's take this example. Okay, so what does binary search will do? We'll have a left pointer and we'll have a right pointer. Left is initially 0, this is 0 1 2 3 and 4, and the right would be 4, right? So first I would check basically, is mid actually matching with my criteria or not? Yes, it is matching, right? So this could be one of my solution. I want to look for an item which is maximum, which is nearer to the left, nearer to the right, right? We want the maximum index at which it is actually matching, right? So this could be one of my possible solution, right? So I will be also having a variable called answer, which will have the maximum beauty which I have gained so far. Okay, for given 3, the maximum beauty gained is 4. So I have to basically search in the remaining half, right? So here the left would be 3 and right would be 4. Mid would be 3 plus 4 by 2, which is 3, right? So again I have basically met my criteria. So again I would update my answer, right, which is with 5. So the so far answer is 4. Now I have encountered a maximum beauty, so I'm updating my answer. So again I have to search in the remaining space whether there could be one more element, there could be possibly one more element called 3 comma 6, right? We don't know, so still we have to search in the remaining half, right? So what I would do, I would basically update my left pointer again. I would basically update my left pointer again to 3 plus 1, which is 4, and this will be again, this will remain same as 4. So what would be the mid in this case? Mid in this case is 4, right? So 4 plus 4 divided by 4 is again 4. So again I would be updating. Am I looking at the desired value? No, right? I'm not looking at my desired value. My desired value is 3, but the mid is basically 5 in this case. The value of the price is 5. So I have to look in the other half now. So I have to basically reduce my right. So the right would be reduced to 4 minus 1, which is 3. So we will basically stop at this particular point of time. When right is greater than left, we have to stop, and this would be our answer. So right. So let's jump into the coding question. The key motive over here is basically we have to use binary search, and we have to sort the array and use the binary search. That is the main thing which you have to observe in this particular problem. Okay, let's jump into the Leetcode. Okay, yeah. So firstly we have to create an array called answer, which would basically contain the maximum beauties of maximum beauties, right? So let's have this. Okay, so the length of this array would be equal to the length of queries, right? Which is queries dot length, right? Let's also have this over here, right? And I also mentioned that we have to sort our items first, so let's just sort it. Let's first sort this, right? Arrays dot sort items. We have to also pass a custom or comparator, which should basically sort based on the first element. Okay, now that our array is sorted, now that we have to update the maximum so far in the same array, right? So we have sorted. Once we have sorted, array would basically look something like this, right? And we should also something like this, and we should also update the maximums, right? So the first element would be 1 comma 2, and the second element should be 2 comma 4, which is maximum of 2 and 4, which is 4 over here. So we have to iterate from the first element. So 0 index would be the same, there won't be any effect on this. So right from here there will be effect. We have to compare with the previous max so far. So for int items dot length I plus plus, have to items of I comma beauty is basically the maximum of current beauty, which is I comma I of 1, and the beauty maximum beauty so far, which would be present in the previous element, right? So now that I have updated my array, I have formed a new array with this particular with this particular conditions, okay, with this particular desired thing. Okay, now that I have to loop through my query and identify the maximum beauty which I can get. Okay, so let's just iterate through my queries. Okay, and I have to get the maximum beauty which I can get. Okay, let's say that we have a function to get max beauty, where we will be passing the current query, which is queries of I, which is the current query, and we'll also pass the items. Okay, we have to pass this. Okay, now that we can simply write in our answer. We have to write this particular function in order to complete our program. So let's write the particular function. So we have a query, and it also takes an array of items. So we have to first define a variable called left, and we should also define a variable called right, which points to the end of the array, and we have to perform a task while left is less than or equal to right, and we have something called mid, which is basically left plus right divided by 2, and if if uh, if items of mid price, if it is greater than the query which we are looking at, in that case we have to basically move to the right side. In other case, this could be our possible solution. In this case, we have to basically define a variable called max beauty. So max beauty is basically math.max of also shift our left pointer to mid -1. Sorry, we have to move to the other side, right? So once it is done, we have to return our max beauty, right? I think we have done with our coding part. So let's try to submit this. Yep, it has worked the test cases. Let's try to submit the solution as well. Yeah, it has also solved, satisfied all the test cases. Yeah, I hope this is helpful. Please subscribe to my channel for more such coding videos. Thank you.